So here's a video about 3.9, which is related rates. So these tend to be word problems. So here's, and I'm just going to show you through examples. So say we have a right triangle ABC. I've drawn it here. Point A is going to stay still. Point B is moving. And then this is a common theme in related rates. Things are changing. So point B is moving up at 1 meter per minute. Point C is moving to the left 2 meters per minute. And the question is, what is the rate of change of the area of the triangle when AB is 3 and AC is 10? So let's set up our variables. So B is moving and C is moving, but A is staying still. And this is also a question about the area of a right triangle. I know that the area is 1/2 base times height. So then this would be the base and this would be the height. So why don't I call this B, little b, and I'll call this distance little h. And yeah, I'll call the area A. And the question is about what is the rate of change of the area. The rate of change is the derivative with respect to t, time. And this is another common theme in related rates problems. When we say rate of change, it's always with respect to time. So according to the formula, first of all, this 1/2 is just a constant. So now I can do the derivative of b times h, and I'll just put parentheses to make sure that I remember the 1/2 gets distributed. And then what would be the derivative of b times h? Well, I'm going to use the product rule, so it would be b times the derivative of h. Here's the derivative of h, plus, and then I would have the derivative of b. Here's the derivative of b times h. So what I have to do now is I have to plug in information that's valid at the instant in question. Let me underline that phrase. This is an abbreviation. I think I might be the only person who really uses this abbreviation, but I find it useful in related rates problems because things are changing. You can talk about what things are at different times, but there's always a particular instant that the question is about. In our case, the instant in question is whatever instant it is when AB is 3 and AC is 10. So actually, I won't do this all at once. I'll collect my information. Well, little b, that's also AC, so that would be 10. At least at the instant in question it is. And keep in mind, once again, b is changing in this problem, but at the instant in question, it's 10. H, at the instant in question, that's the distance from A to B, so that would be 3. What other information do I need? I'm going to need dH over dt, and I'm going to need dB over dt. How do I get these? Well, dH over dt, it's the rate of change of h. So how fast is h changing? Well, we were told that b moves up at 1 meter per minute. So I would say that h is increasing at 1 meter per minute. And actually, let me put units on all of these. These are meters. This one's meters per minute. And dB over dt. So now let's be careful here. C is moving to the left at a rate of 2 meters per minute. So I would say that B is decreasing at a rate of 2 meters per minute. So for dB over dt, I would write -2, because it's getting smaller at a rate of 2 meters per minute. So pay attention to when you're doing this, whether it should be positive or negative. But then now I just have to plug all this information in here, and then I'll be good. 1/2 10 dH over dt is 1 plus -2 times h, which is 3. So this is 1/2. Let's see here. 10 minus 6 is 4. So I should get 2. And let's put units on our answer. Actually, okay, one way to get units on our answer is for me to go back and put units on all of these. Like this was meters, this one was meters per minute, this -2 was meters per minute, this 3 was meters. So if I look at these units, it looks like the units should be meters squared per minute. There's another way to figure out what the units should be. The units of dA over dt should be the units of A over the units of T. A is the area. We would measure that in square meters, and T is time, and we're measuring, in this problem, we're measuring that in minutes. So the units of A is meters squared, units of T is minutes. That's another easy way you can figure out what the units should be. Okay, so this is a pretty typical related rates problem, and they are word problems, so they can be hard. The hardest part is setting them up. And the issue is it could really be anything. And in this case, we had a triangle and there were points moving around. You could set up a related rates problem for almost any geometric problem when points are moving around, and ask about the shape of the area of whatever shape you want. It doesn't have to be a right triangle. It doesn't have to be about area. It can be a lot of different word problems you can set up this way. After you come up with the equation, then it's always the same. You take the derivative with respect to t, and you plug in all the information about the instant in question, and you solve for whatever you need to solve for. So the hard part is setting it up. Let's see, what's next? Okay, so here is a classic ladder sliding down a wall problem. These examples are very typical when people are introducing related rates questions. So we have a ladder. It's leaning against a wall. The ladder is 5 feet long. The base of the ladder is sliding away from the wall at 0.1 feet per second. And then the question is, how fast is the top of the ladder sliding down the wall when the base is 3 feet away? So if you can imagine, the ladder's like this, and then the ladder's moving away from the wall, so it's like the bottom is moving away and the top would move down. So yeah, maybe my hand is too big. it's going like this over time. And I mean, eventually, I guess the ladder would just be laying flat. So that's how it's moving. So this, I mean, this problem, it has a right angle in it, but it's not about the area of the right triangle. It's about how fast the top of the ladder is moving down. So I'm going to label some relevant variables here. Why don't I call this x? This is the distance from the base to the wall, which is clearly relevant to this problem. For example, I know how fast the base is sliding away from the wall, and I also know that at the instant in question, the distance is 3. So this is clearly a relevant variable. Also, the variable I'm actually being asked about is this, so I'll call that y. Actually, I'm worried that this, if I write too far to the left, then it won't show up on the scan, so I'll write the letter y right there. Yeah, and let me point something out. I'm not going to give the length of the ladder a variable name. I could call it z or something like that, but I'm only assigning variable names to things that are changing. The length of the ladder is not changing throughout this problem. The length is always 5 feet. It's just that it moves, it slides around, but the length of the ladder is always 5 feet. So if it's always 5 feet, I'm comfortable just labeling it 5 feet. You know, at the instant in question, x is 3, but I didn't just write a 3 here because that's only true at the instant in question. X is moving around. X is like the ladder is sliding away. So x isn't always 3. It's only 3 at the instant in question. So that's the difference between why I don't put a 3 here, but I do put a 5 here. This number is not changing. This one is. Yeah, so now I write down, you have to write down some kind of equation. And since I have a right triangle and I'm talking about the sides, I'm going to use Pythagorean theorem. So here's my equation. I'm just going to go ahead and take the derivative of both sides with respect to t. Now, when I do that, this is a lot like implicit differentiation, where if I'm doing the derivative of something with respect to t, I always have to think about the chain rule. And, for example, the derivative of x squared would be 2x, but then I have to multiply by the derivative of the inside because of the chain rule, which would be dx over dt. Similarly here, I've got to do 2y dy over dt. Now, of course, it would be easy for me to just write 25 there without thinking very hard, but that's wrong. The derivative of 25 is 0. So don't forget to do the derivative of a constant if you get that. So here we are. Now I would like to plug in some values that are valid at the instant in question. So at the instant in question, what do I know? I know that, let's see, I'll just read from the beginning here. The base is sliding away from the wall at 0.1 feet per second. That would be how fast x is changing. So dx over dt is 0.1 feet per second. how fast is the top of the ladder sliding down the wall. And yeah, so this isn't something we know, but let me take note of it anyway. This is talking about dy over dt, right? How fast is the ladder sliding down the wall? Y is the height of the top of the ladder, and how fast is it sliding down would be the rate of change of y, so dy over dt. But they're not telling us that. That is the question. So this is the unknown. This is the one I'll have to figure out. What I should be able to do is I should be able to fill in all the values of everything here except for the unknown, and then I'll just solve for the unknown. So what do I have left? I have dx over dt, dy over dt I don't know, but that's okay. That's what I'm going to figure out. I still have to know x and I have to know y. X is actually, they tell us that because at the incident question, the base is 3 feet away. So x is just 3 feet. And now I have a real question. What is y at the incident question? Sometimes you won't be told these things. The value of y is not anywhere in the instructions. No matter how closely you read it, it doesn't really tell you. But we can figure it out. If you run into something like this, go back to the original equation before you took the derivative and try to plug stuff in here. Yeah, so I shouldn't make this too hard. I'm just putting in the value of x at the incident question. So 9 plus y squared equals 25. Y squared would be 16. So for y, I'm going to put 4 feet. I'm not going to put -4 because, I mean, the ladder is not underground, right? So let's say that y is the positive square root, so y is positive 4. Okay, so we did it. We figured out all of these values. Of course, it took some work, and that happens sometimes, and that's okay. Now let's plug everything in, and then we can figure out dy over dt. So 2 times 3 times 0.1 plus 2 times 4 dy over dt, because that's the one I don't know, equals 0. Yeah, so then this shouldn't be hard. 0.6 plus 8 dy over dt is 0. So this would be like negative 0.6 over 8. Let's get a decimal for that. So it's exactly this. I'm not rounding or anything. And this should be, what should the units be? Let's figure this out the easy way. The units of y divided by the units of t. So y is a distance, and distances are measured in feet in this problem. So feet, and t is time, that's seconds. So if we read the question carefully, it says, how fast is the top of the ladder sliding down the wall? And of course, if the bottom is moving away from the wall, then the top would be sliding down. So it makes perfect sense that we got a negative answer. But maybe it also makes sense to say, so it's sliding down at 0.075 feet per second. So I don't mean to be too picky about this, but it's just an issue of like what direction are we talking about? the rate of change of y was negative because y was moving down, like it's decreasing. But if the question is how fast is it sliding down, you're already specifying that it's going down, and then you would not write the negative here. So I don't plan to be too picky about that issue, but it can be, you might want to change the sign of your answer if the question is already specifying that it's moving in the negative direction. Then your answer shouldn't be negative. Okay. I have one more example. And yeah, I can probably do this. Maybe the video will end up like half an hour long or so, but that's okay. A bird flies horizontally directly over your head. So like, let's assume that in the beginning, of course, we assume that the directly overhead and like the ground is perfectly horizontal, all of that good stuff. So a bird flies directly over your head. It's flying 10 meters per second. It's flying in a straight line, and it's 100 meters above you. So I already said it flies horizontally, so it's going to stay 100 meters above at the same height. The question is, how fast is the angle between the bird, you, and the ground changing 10 seconds after the bird is over your head? The first thing I'm going to do is draw another picture, because this is a picture that is just when the bird is directly over your head. So maybe the height of the bird is 100 meters. Say, yeah, I'm not too good at drawing birds, but say the bird is now here. And let's say, right, so this is intended to be all right angles. The height of the bird is always 100 meters, but let's say this horizontal distance is like, I don't know, x. Yeah, and the question is about the angle between the bird and you and the ground. So actually, let's assume that means the angle between the bird and like your feet and the ground, because I don't want to worry about how tall you are. So let's say that that's theta. So I drew a picture, I labeled some relevant variables. There are certain things that are not changing. For example, this 100 is changing, which is why I just wrote 100 there instead of a variable name. This value of x is changing, and theta is changing. So what I would like to do is write down an equation that gives me a relationship between the relevant variables. And since one of the relevant variables is this angle, I'm thinking about trigonometry. So what do I know about this right triangle? I know this length is x, I know this angle is theta, and I also know this, because this would also be 100, right? So it looks like, if I think about my trig functions, and I think about SOHCAHTOA and that type of stuff, I know the opposite and I know the adjacent, so maybe it would make sense to talk about tan theta, because tan theta is opposite over adjacent, right? So here's my equation, and I am about to do calculus, so let me put this in a friendlier form so I can take the derivative easier. Let's take the derivative of both sides with respect to t now. Yeah. Secant squared theta d theta dt, right? Because the derivative of tangent is secant squared, but then I have to think about the chain rule, and I have to do the derivative of the inside. That's why there's d theta over dt there. And that would equal the derivative of this. So that would be 100 times negative 1 x to the negative 2 times the derivative of the inside, dx over dt. Okay, so now I am at the point where I just have to plug in the relevant information that's valid at the instant in question. So, at the instant in question, what do I know? I mean, I'm looking at this. It seems like I basically don't know anything. So let me think. All I know about the instant in question is that it's 10 seconds after the bird is over my head. So that should be enough information for me to figure out x, right? We know that the, oh, sorry. A second ago I said we don't know anything. We do know something. The problem said that the bird flies 10 meters per second. So that's dx over dt. Right, the bird is flying horizontally, so that's how much x is increasing, 10 meters per second. But right, let me get back to figuring out x, because we're going to use that information. If the bird was directly over your head 10 seconds ago, and it's moving 10 meters per second, then 10 seconds later it should be 100 meters away, right? That's how we figure out x. Now, what else would I need to know to use this equation? I need to know d theta over dt, and I also need to know theta. One of these things should be the unknown, and if I look at the question, it says how fast is the angle between the bird, you, and the ground changing. So that would be how fast the angle is changing is d theta over dt. So that's the unknown. But there can be only one unknown. That means I have to figure out everything else. So I'm going to need to be able to figure out theta. To figure out theta, I'm going to use the same method we did last time. I'm going to go back to the equation right before we took the derivative, and I'm going to plug in the information that I know. So tan theta would be 100 over whatever the value of x is, but we figured that out. That would be 100. So theta is arctangent of 1, which is pi over 4. Okay, now we plug all that in. And that would equal negative 100 times x to the negative 2. Right? So, yeah. Pi over 4 is 45 degrees. So I'm drawing my 45, 45, 90 triangle like this. So this, based on this picture, I can remember that the cosine of pi over 4 is 1 over root 2. So that would mean the secant of pi over 4 is just root 2 because it's the reciprocal of that. So secant squared would just be 2. Meanwhile, what is this? So this is 100 over 100 squared. So I can just call that 1 over 100. So then d theta over dt is, I would divide by 2, so I guess I would get negative 1 over 200. And what should the units be in? Well, it's the units of theta divided by the units of t. The units of theta, since we're doing calculus, are radians. The units of t are whatever it says, seconds. Okay, so I know on the online homework there's a few different types of questions, but it all just boils down to setting up the equation. You have to draw the right picture, and then you have to write down an equation that expresses a relationship between the variables that you have in your problem. Setting that up is the hard part, and it's always different. So you have to be able to do that part, but then from that point on, the steps are always the same. You take the derivative. Don't forget to write things like d theta over dt and dx over dt. Remember, you have to use the chain rule, and this is a lot like implicit differentiation. And then you just plug in all the values that are valid at the instant in question, and you should be able to figure out like whatever the one thing out of this information that you don't know, you should be able to plug in the rest and figure out for the one thing that you don't know. Okay.